Alright, so for this problem, we're going to be going over force that is applied on a book. Alright, so the problem says a rightward force of 7 newtons is applied to a 2.5 kilogram book in order to move it steady across the desk. Consider frictional forces. Right, so we're going to take for account all friction forces, and we're going to be finding the coefficient of friction. Alright, so as you can see in the center, we have a book that weighs 2.5 kilograms. And then you can see onto the left, you see the 7 newtons being applied as a force. Whenever you move an object, there's always friction, right? So you can see, let me go ahead and highlight this. So this is going to be our frictional force, right? And notice there's a K, there's a subset K. This K means it's going to be a kinetic friction. How do we know it's going to be a kinetic friction? Because the object is moving, right? When anything is moving, it's considered kinetic friction. Let me elaborate a little bit more about the difference between kinetic and static friction. So when an object is sitting on top of a desk, right? It's just sitting still. There's no friction whatsoever, right? Because it's sitting still. But as soon as we start moving it, there's some sort of friction, right? So let's assume this box right here weighs, let's say 170 pounds, right? Or because we're doing kilograms, let's do kilograms, right? So it's really, really heavy, right? So it's extremely heavy. You guys ever notice that whenever you push a really heavy box, it's really hard at first, right? It's really, really hard. And then you see movement happen, right? And then it's no longer hard, right? It's moving steady. It's still heavy, but it's not. Once it's moving, it's easier to like continue to move, right? Pushing it, right? So that's the difference, right? Static friction. Let me go ahead and label it here. Static friction. It's right before it starts moving, right? So as soon as you start first seeing it move, that's when kinetic friction comes in, right? So in this problem, because we have the object that is moving, so we're applying 7 newtons of force onto this book. We're going to be working with kinetic friction, okay? So hopefully kinetic friction and static friction makes sense as of right now. So the formula that we're going to be using to find the coefficient of friction, it's going to be mu of kinetic friction equals the frictional force for kinetic divided by the normal force. Okay. So the question here is, how do we find what kinetic friction is? Right. So Newton's third law states that when a force is applied on an object, the object applies the same force against it, right? So that's what this is signifying. So if I'm pushing the box 7 newtons to the right, the force of kinetic friction, it's the same thing. It's going to be pushing back 7 newtons, right? So let's go ahead and write that down. So the kinetic force, it's equal to the force, right, which is equal to 7 newtons. Okay, so hopefully this is making sense. We're gonna, let's see, let me move this over and erase this. So now we know what the top part is, right? So we know that the kinetic force is going to be 7 newtons, right? So now the question is, what is the normal force, right? So we can figure out the normal force. Let me go ahead and erase this to clear out some space. So the normal force, right, normal force equals m times a, right? Mass times acceleration, right? Wait, sorry. One thing that I forgot to mention, the normal force is the same thing as the weight, right? The weight, right? And then weight is the gravity that force is pulling you, right? So we know that the mass is 2.5 kilograms. And keep in mind that we're going to be multiplying units with units, okay? So right here it's going to be 2.5 kilograms times, let me put a little x, times acceleration, which is 9.8. And I'm running out of space. So it's going to be 9.8 meters per second squared, right? That's acceleration that gravity pulls us. All right. So when I multiply this, I get, it should be like 24 probably. Let's see what that is. 2.5 times 9.8 equals 24.5, right? And then we're going to multiply kilograms times meters per second squared, right? So it's going to be kilograms times meters per second squared, right? So that is actually newtons, right? So this right here is going to be newtons, right? Because that's what that is. Newtons is kilograms times meters per second squared. All right, so there you go. We found the normal force. Now we can go ahead and put it back into our equation. So we have 24.5 newtons, right? So the newtons cancel out, right? So now, and that makes sense because the coefficient, mu, is actually unitless. So it has no unit, right? It's a coefficient. So let's go ahead and do this division. 7 divided by 24.5. And that's going to give us 0.285, right? And again, it has no unit. And we can approximate it to 0.29. No unit, right? So that's mu. It's approximately 0.29. And that's what our coefficient is, right? So hopefully you guys understood more or less of how to find the coefficient, as well as the difference between kinetic friction and static friction.